Hello, dear student. How are you? I hope you are all will be fine. I'm also fine. Thank you. Welcome to your channel, Hazard Science Group. Let's start today topic. Today is our topic acidity of alcohol. Acidity of alcohols and phenol. So let's start today topic. Today topic acidity of alcohol. The formula of alcohol is ROH. This is the formula of alcohol. OH is the functional group of alcohol. OH is the functional group of alcohol, and R is the alkyl group. Alkyl may be ethyl, propyl, butyl, pentyl, hexyl, heptyl, and this may be substituted, di-substituted, tri-substituted, secondary, primary, tertiary, and so on. So let's start. According to Bronsted and Lowry concepts, those species that can donate proton easily, that can donate proton easily will be called good acid. Good acid. Those species that can be donate proton easily will be called good acids. So in case of acidity of alcohol, where there is ROH groups, OH bond present, as the OH bond become more polarized, it means that this bond will be break easily. So that's why they will be generate anion and cation. Cation will be proton, called proton, while anion will be alkoxide ion, that will be called alkoxide ion, while this hydrogen will be called proton, and this proton will be abstracted by any base when you use here any strong base. So what the factor that will be involved in the what factors can affect the polarization of this bond, this oxygen and hydrogen bond? So let's start in today's topic. We will be discussing these factors. One factor is inductive effect. It means that the inductive effect has very great role on acidity. Inductive effect also resonance effect. It has also great effect on the acidity, strength of acidity. Also hybridization. Also delocalization and resonance phenomena is same. So these all few factors are involved in this. Let's suppose what is meant by inductive effect. When you have any two compounds, that is CH3O, CH3, CH2OH. One is this compound and another is this compound CH3, CH2, CH2, CH2OH. Which one will be more acidic? Which one which one hydrogen oxygen bond will be more polarized? In which one case will be more polarized? In case of greater the number of alkyl groups, greater the number of carbon as the chain longest, it will increase the electron donating tendency toward oxygen atom. So that's why oxygen will become more electronegative as the density of electron increases on the oxygen. It means that in this case hydrogen cannot be removed easily as a proton, while in case of when there is not enough long chain, as like here and there is four carbon atom, while here in the above one case, in case of A, in case of B, in case of A here is O, here is 2 carbon, so that's why that has not enough effect on the increasing electron density on this oxygen. That's why in this case this bond will become more polarized. The electron density is not enough increase that affect the hydrogen removal of hydrogen, so that's why here the hydrogen can be affected, hydrogen can be removed easily. Why hydrogen can be removed easily? Here is a few reason, but the biggest reason is, here is two reasons, or two main reason. Which one will be stronger acid and which one will be weaker acid, or you can say that in which case the bond will be more polarized and in which case the bond will be less polarized, or in which case the hydrogen can be donate easily, in which case hydrogen cannot be donate easily. Two main reason of this factor. Let's start. Let's take the correct position of the camera. Two main reason. One reason is that let's suppose in both cases CH3 CH2OH, let's suppose the bond become break and produce ions CH3 CH2O negative plus H positive. These two ions are produced in case of A, in case of ethanol, while in case of butanol CH3 CH2 CH2 CH2OH. In case of butanol, it will be generate butoxide ion CH3 CH2 CH2OH, O negative plus H positive. They both, in both cases, these two ions are produced. Where in first cases, in case of ethoxide ion, here is also proton generated. In case of butoxide ion, here is also proton generated. In both cases proton has same size and same electronic charge, same positive charge. In both cases the charge on the proton are same, the size of the proton are same. So let's suppose this is the size of the proton, this is the size of the proton. In both cases this is the size of the proton, this is the size of the proton that are generated by the ethoxide ion of the A compound, while this is the proton, while both have the same size and same shape and same charge. While this proton, the size and the shape and the charge on this proton, this is the proton of that generated by the butoxide ion or the compound that are B. While in case of here, in this case in case of ethoxide ion, here is two carbon compound, two carbon present, so two carbon chain present, so these carbon will be, and we know that the alkyl group are the electron donating groups, so they will be donate electron toward this oxygen atom, so that's why the electron density on this oxygen atom will be increases. But in case of four carbon chain, it will have more effect, it will have more tendency to increase the electron density on this oxygen atom. So it means that the electron density on the oxygen in case of butoxide ion, it will be very greater. Let's assume that the electron density on the oxygen of the ethoxide ion will be like that, while in case of, let's suppose that and we know that the electron density on the oxygen in case of butoxide ion will be very greater as compared to the ethoxide ion. So let's suppose this will be like that will be greater than this one. So in which case, let's tell me, in which case the interaction between positive and negative will be high according to column law. Let's pause the video and answer me in comment section. So I show you, according to Coulomb law, according to Coulomb law, what say Coulomb law? Coulomb law say that the interaction between that, or you can say that the attraction or repulsion between two charges will be depend upon the size, will directly depend upon the size of the charges. Mean greater the charges, greater will be interaction. Also opposite the charges, enter attraction will be present, same the charges repulsion will be present, but but charges, interaction between charges, interaction between charges depend upon the size of the charges, size of the charges. It is according to Coulomb law. It also depend upon the size of the charges, and they are the magnitude of the charges. So as the magnitude of the charge increase, as the magnitude of the charge greater, it means that the interaction between these two charges will be greater. So here in both cases a positive charge are same, while in this case, in case of B, in case of butoxide ion, the electronic charge on the oxygen atom is very greater. That's why this negative charge, this positive, the interaction between these two charges will be very greater. While in case of above, in case of ethoxide ion and this proton, this has not enough big charge. The interaction between these two charges, the attraction between these two opposite charges will be not greater as like in this case. So that's why in case of butoxide ion, in case of butoxide ion and the proton, the attraction between butoxide ion and proton will be very greater. So that's why the separation of this bond, or the breaking of this bond, and to separate the butoxide ion and hydrogen, it will be difficult. So that's why this compound cannot be shifted toward right side, but this equilibrium will be shifted towards the left, and will generate in the solution, in the mixture, in the product, the concentration of this reaction, the concentration of the butanol will be very greater as compared to the butoxide ion. So that's why the as a whole, in the product of the mixture, in the product of the mixture, not the hydrogen concentration is much high as compared to in the ethoxide ion. In ethoxide ion, the equilibrium will be shifted toward right side, because the interaction between the ethoxide ion and the proton will be not enough, the attraction will be not enough as like in the below case. So that's why in the result, the number of proton, or the proton will be increased, the hydrogen concentration will be increased, and we know that the concentration of hydrogen directly depend upon the acidity. So that's why the ethoxide ion will be very greater, will be more acidic than butoxide ion. Means the inductive effect also depend upon the acidity. These are the two factors, that is inductive effect, that are electron withdrawing or donating groups. These are the electron donating group. Let's start any example of any with electron donating groups, not donating, electron withdrawing groups. Let's compare electron donating and electron withdrawing groups. Let's suppose this is the one compound ClCH2OH, and this is the another compound CH3CH2OH. This is the, in case of chlorine is electronegative element, and it withdraw the electron from this oxygen, it means that it decrease the electron density on this oxygen. While in case of ethanol, this alkyl group will increase electron density on this oxygen, it will donate the electron on this oxygen, that is the electron donating group, electron withdrawing groups, withdrawing effect, while this is the electron donating effect. In case of, let's suppose in both cases, here is also partial positive, partial negative charge, because electronegative, oxygen is electronegative, while hydrogen is less, hydrogen is electropositive, so that's why it will have partial positive charge. Let's suppose in both cases, in equal solution, they generate CH, CH2O negative plus H positive. Similarly, here they generate CH3, CH2O negative plus H positive. So in both cases, which one will be more acidic, which one solution will be less acidic? In the solution, in above solution, here is electron donating group attached that withdraw the electron from the oxygen atom. That electron withdraw the itself an oxygen negative charge present. When the electron withdraw from this oxygen, it means that this chloride ion or this electron withdrawing group stabilize this oxygen, this negative charge. So that's why these ions will be stable, and this ion will cannot be easily reactive on this head, on this proton. So that's why in the product or in the solution, the hydrogen ion concentration will be increases, while in case of electron donating group attached, in case of alcohol, this is electron donating group attached. So this electron donating group, that an oxygen itself electron negative charge, electron density is increased, while when we add the further electron donating group, it further increase the electron density on this oxygen atom. So that's why oxygen become more electronegative, the reactivity become increases, reactivity of this species become increases. So that's why it will be properly, it will have efficiency to attack on this proton. So that's why the equilibrium will be shift towards left, and in the product or in the mixture or in the solution, the hydrogen ion concentration will be less, while the concentration of alcohol, the concentration of this product, or not this product, the concentration of the reactant, or you can say that the concentration of the ethanol will be very greater, but the concentration of proton will be very less, hydrogen ion concentration will be very less. So that's why this will be less acidic, while in case of in electron withdrawing groups, the hydrogen ion concentration will be greater, because the ion will be, the negative ion will be stabilized. So that's why the positive charge or the hydrogen ion concentration will be increased. So it means the conclusion of this topic will be, the conclusion of this topic is electron withdrawing groups attached with alcohol, electron withdrawing groups attached with alcohol increase acidity, while electron donating group attached with alcohol, it decrease acidity. These are the two postulates, two results. Let's suppose in this case, Cl, Ch, O, Ch2, OH, while this is the another case, Ch, Cl, CHOH. Which one will be more acidic, which one will be less acidic, sir? Please pause the video and answer me in comment section. Okay, here in both cases, in one case is one chlorine attached, while in another cases two chlorine attached. In both cases electron withdrawing group attached, but in one cases, in the below cases, more the electron withdrawing groups, while in above cases less the electron withdrawing groups attached. So we know that as the electron withdrawing group increases, it increase acidity. Why it increase acidity? Because it stabilize the negative charge on the oxygen atom, so that's why it increase. So that's why the hydrogen ion concentration in the solution will be increased. That's why this ion will be more acidic in the solution, while the first case will be less acidic in the solution. I hope my points will be clear. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in description box. Let's give me answer of this. CH3OH. Which one will be? Write down the acidity order. Write down the acidity order. Comment me. Its answer will, you will be answer of this question in comment. Write the acidic order, decreasing acidic order, decreasing acidity order of the following. Number A, CH3OH. Number B, CH3CH2OH. Number C, CH3CHOH CH3. Number D, CH3CHOHCl. Number E, CH2CH2OH. The decreasing acidic order, write me in comment section the decreasing acidic order of these 5 compounds. Okay, thank you. Also please subscribe my channel, it makes me feel happy that my students are supporting me. Thank you very much, very best of luck my dear student. The basic hint for this, the main hints for this problem is more the electron donating groups it decrease the acidity, more the electron withdrawing groups it increase the acidity. Okay, thank you very much, very best of luck my dear student, very best of luck.